All right, good morning, everybody, and welcome back to another episode of Breakfast with Data in this our data modeling series. This is the day two of data modeling. Yesterday, we made the case for why data modeling still matter. A data model is a set of decision about meaning, and meaning is the thing that the model cannot decide for you, right? What your data entirely mean, you have to feed it, and a lot of time this meaning will come from the business. Then you, as a data practitioner, just have to put it in place. Today we will look at we'll go to the first principle with the oldest idea in the field, which is normalization. So when you talk about data, modeling data, it all begins from normalization. Now, what are we going to do? We are going to look at why normalization matters, what is data normalization, and the different principles that are involved in normalizing data. So, what is data normalization and what does it even try to do? Why should we normalize data? Because when we say we are normalizing data, a lot of times we are breaking this data into multiple tables. But if I start with that, that will kind of, it's not always about, oh, we have to split the data into multiple tables, we have to remove redundancy. Normalization is not about tidiness. Each normal form removes a specific way redundant data, that the redundant data is going to betray you, right? So normalization is all about reducing redundancy in data, in your data set, right? And when you are removing this redundancy, why do we even should we remove some redundancy, and why should we try to normalize our data and put them in a standard, in the best form, in the third normal form, which is most likely it's normalized. When we say data is normalized, there are three kinds of anomaly that we want to avoid. The insertion anomaly, right? You cannot record a new restaurant until it has taken an order, right? Because restaurant fact live inside the order row. That's an insertion anomaly, right? So if you have a order, right, and a restaurant does not exist, that's a problem, right? The problem is existing because you've inserted into one, you cannot this thing. A restaurant changes its name and you must update it in hundreds of row. You also avoid update anomaly, right? Why should you update in several times instead of just updating in the base table that joins? Then there is the deletion anomaly, right? Which is let's see, a rider has been deleted from the riders table, right? And every order that this rider has placed suddenly have an orphan rider. So those are the kind of things that you are very, very careful with when we try to have our table and we normalize it, right? If we want to update something, it's easy for us to update, it's easy for us to insert, and a normalized table is built for us to be able to write data quickly. Maybe let me take a detour from my this thing, and let me explain something to you, because when we look at data system, this is why normalization and denormalization is going to make sense to you. There are always operational systems, right? When I say operational, these are systems that you use, the business is using. This may be your CRM, your help desk app, it might be your call banking, it might be um, your e-commerce store, your website, your whatever you have that is the thing that is powering the business process, right? It might be the food app, right? Maybe it's Uber, it's Childek, it's Glovo. That is capturing the data. This is often your data source, right? Of course, this guy may rely on some other data sources, some API, some gateway. I mean, if you want to make sales and all the rest of them, but all of this is operational. Now, there is another kind of data when you find it an organization, they come in two flavor, and this one is analytical data, right? So you have the operational systems and you have your analytical systems. Now, you must have operation first before you begin to analyze. Remember, analytics is all about deriving, getting value out of data, right? Yes, there might be data that you derive as a result of analysis, right? But the bulk of the data is coming from a business operation, because this is the business operation that you are trying to improve, right? Excuse me. Okay, sorry for that short break in transmission. So when we are talking about operational system and analytic system, these are two things, and the way we organize the data, in this in fact, this is one of the reasons why data modeling is very, very important, is different, right? Because for when you are doing operations, maybe a customer is writing something. We have here now, we have what we call the OLTP. You would have heard of OLTP systems, online transactional processes. Now, when we say transaction, transaction does not mean your bank sending money. I know those of us that love money, anytime we hear transaction, we are already thinking money, 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 money. No, transactional in this particular case is more like any activity in a business process is a transaction, right? So a rider being matched to a particular dispatch, that is a transaction. A customer getting his food, that is a transaction. Even a customer logging into the app is a transaction, right? So every of these, and we want this to be very, very fast. We want to update one record, we want to update it in one place. So these systems are built for fast read and write. You understand? I want to quickly get information into the system, and I want to be able to quickly get information out. So I want to register a customer. What database will I register his name? A customer has placed an order. What are the different databases that are concerned? What are the entities that will be involved in delivering this food? A new restaurant has come on board. They want to update their menu. Maybe the food is what is it called? My food is 5,000 naira a plate before, and economy has affected the business, so cost of production has gone up. I want to quickly update my menu, right? From this menu, this thing, if I have to touch every single row of everybody that has ordered before so that I can update my menu. You understand? Because I've sold millions. I want to do analytics later. I will need to go back, and that is a problem, right? I need to be able to just go to just one table and make the update that I need in just one place. Or maybe I no longer sell a particular food again. I want to delete something from my menu. I need to go to just one place and delete that same record. Of course, deletion in a lot of databases we carry a lot of these things. So here, we don't like redundancy, but for analytical process, we have what we call OLAP, OLAP, right? Online analytical processing. So these systems that are analytical is how you improve operations. So get this, right? I talk about value. This is what you are doing, what the business is doing on a day-to-day basis, right? We are trying to say, this is the operation we are doing. Think about it. Whatever you are doing in your office or whatever you are doing in your business, right? At the end of the day, and we are going to use this food business, this dispatch riding, delivering of food business. You want to sell food to one customer. That's interesting. That's operation. You want to match rider. You as a rider, you need to pick up certain number of orders. You want to go here, you've picked the order, you've delivered, you have ordered food, you have delivered. Analytic system or analytical data will say how many orders were made today and how many riders did we have. So we have one rider fulfilling, maybe we can say average dispatch per rider, average number of deliveries per rider, and we'll see that our riders are delivering maybe 50 orders per day. That's too much. That's overwhelming. How many orders go undelivered? How many orders get cancelled because customer got tired of waiting for that order? Now, you now decide that, okay, fine. Instead of how do we do, what decisions should we make? And these are more data science. Sometimes this might even involve some research, right? Because, and this is not the session for it, because there are A/B testing, there are a lot of stuff that we can derive out of this data. Then we start saying, hey, look, I think this operation, if we add more riders, it will help our operation. But how did we come about that? It is not on this system that gave us that information. It is the analytics that we did on it. Now, analytics aggregate things around column. So you are looking at aggregate stuff. Now, here, redundancy is not a problem. In fact, we like it. And if you followed the database, this thing that we've been doing, you realize that, we have less joins because the data is heavy, is big. This one is designed for the joins to be efficient. You are not getting too many things, but there will be joins definitely, right? But you want fast read, fast write. When you start doing aggregative calculation on operational system, you are doing it wrong. Your system may be slow. There might be, depending on the database system, what some folks used to do that year, they will just lock it. There are a lot of other systems that are depending on this. You understand? So that is why here we normalize, here we denormalize. Now let's go back to our normalization this thing. So we now know why we do normalization. Number one, to avoid insertion anomaly, update anomaly, and deletion anomaly. Now let's look at a simple table now, right? One flat table. This is where everybody's record is coming in from. Let's say we have the orders table. We are recording this. Like some people will record in a if you've gone to some of these supermarkets before, you will see one big book. That book that is always long, that's this stuff. And as you are ordering, in fact, they do it in where I order for small shops, right? There is someone that is always writing everything that you order, right? I don't know if they put order number. Of course, they've never asked me for my name before, but let's assume that we have the order ID, we have the customer, we have the customer phone number, the restaurant city, and the items, right? So I bought 2 jollof rice, water, and this thing. Now there is a lot of redundancy here. No, Ikeja, right? This phone number is kind of like redundant because this is Mr. Bello, right? Mr. Bello. The same phone number right? We've written it twice because it's one customer ordering twice. One restaurant is being ordered for twice. Mama put, right? Now the order may differ, right? Because we have jollof rice, we have this thing. This violates a redundancy everywhere, and this violates uh, the first principle of ordering. What now? Let's think about it. For us to be able to for us to be able to arrange our data very well, we must be able to easily match order to customer, to restaurant, to order ID, right? We must look at what depends on what. You understand? From one level to another level. These are a lot of things that the business themselves will come and tell you. You understand? So now for normalization, we have what we call normal form. 1NF, 2NF, 3NF, BCNF, and there is 4NF, 5NF, and it can go up and up and up and up like that. The first normal form, what is the principle of the first normal form? If you look at this, our flat table, right? We have jollof rice and everything. The first principle is that, number one, every cell must hold one value. Every row must be unique, right? So if you look at this, we must be able to say this is unique, this is unique, this is unique. Now, if we look at this, every cell must be atomic, right? We can see that food is not atomic, right? The food item. If you go back here, you can see that this is not atomic, right? We have jollof rice, 2 portion. We have what is it called? Water, 1, right? Suya, fried rice, 2. This Mr. Bello is ordering from a lot of places. But if you look here, you can see that the food item is now unique, right? It's carrying one information, which is just one food, and you are not adding the quantity together like we are doing here. You understand? X2 here, X1, X2 is the quantity. So that items column is carrying 2 different fields: the item that is ordered and the quantity. This is against the principle of what is it called? The first normal form, right? Every row must hold atomic value, just one value, right? And there can only be 1 row per item. Do you get? Now, this is the grain of, we've been talking about the grain. Do you get? So we can see that this is what we call a order line, because look at this. This is one order. Inside one order that Mr. Bello made, we have jollof and water, right? Now, what is this telling us? This same order, we fixed one, which is every cell now have one values, but then we still have a problem here. The name is still repeated multiple times, right? The order is still repeated. So on this table, we don't have a unique way of identifying a particular customer, unless we introduce what we call a composite key, right? Because when you look at it, the combination of order ID and maybe order item will give you a unique this thing, or maybe a combination of this. A primary key on a table is the column that uniquely, or sets of columns that uniquely identify a record, right? So when you say I have a primary key, I have a primary key on my table is what we will check if we want to check if there are duplicates on that particular table. On this particular table, we see that there are duplicates, but there are no duplicates at the same time. Let me put it this way. There are redundant data. Below. But if you look at this very well, you will see that it's a different order, right? So what we try to do is to say, okay, fine. For us to make sure each row is unique, if you look at it, not looking at the order ID as the primary key, but a combination of the order ID and the items, right? And maybe the quantity. That will give you a unique this thing. So we can see that if we take that as the principle here, we can say this table does fulfill first normal form, because with the combination of order ID and the item, we can uniquely identify a particular order item, right? Order line, right? And then we still have some redundancy in this thing. Now that brings us to the second normal form. You know, first normal form is atomic values and no repeating groups, right? Second normal form is no partial dependencies, right? We shouldn't have partial dependencies of something. Every column, right? The order ID for an item, anything that does not depend on the primary key, right, should get its own table. So everything must depend on the primary key. Anything that does not depend on the primary key, they are on their own. So if you look at this, we said the combination of this order ID and item is how we uniquely identify a particular column. So everything should depend on that. If you don't directly depend on that, you shouldn't get your this thing. And let's look at this now. What happens here is now we have the orders themselves and the order item table, right? How is that? Because the Mr. Bello, hey Bello, right, does not really depend on jollof rice, right? Even though it can depend on this order ID, but not jollof rice. So you must depend, and it's the combination of these two that gives us the primary key. So if we are talking about that dependency, we must look at other item at the same time. Of course, quantity is dependent on the ordered item that you ordered, but the customer name, the restaurant city, all of these don't depend on this. So we have in second normal form to split this second normal form, we have to split order items and order. So we know that a order may contain multiple things, and a order belongs to a customer, right? And from the order item, we get to the order. So from order item, we have the order ID. Of course, you can create its own unique primary key again and say order line ID or order item ID. That's totally up to you. But the idea is uniqueness, right? Jollof rice is the order, the jollof rice, water, suya, and fried rice. These are what were ordered, and the quantity depends on them. Here, order ID, customer and restaurant, and customer and restaurant depends on order ID, not the restaurant city. The restaurant city depends on the restaurant, not on the customer, not on the order ID. It depends on another thing. So this is we will now see this now, right? Because in this particular case, when we have this thing, we will see that this is becoming a transitive dependency, right? Whereas restaurant depends on on order ID, right, we've eliminated partial dependency. Everything kind of depends on the order ID, right? If you take a look at it in the innermost sense, but restaurant city does not just depend on the order ID, it also depends on the restaurant. So here we have what we call transitive dependency, and that is what third normal form tries to fix, right? Restaurant city depends on the restaurant, which depends on the order. So if you are going to all dependent this thing, we must depend on the key column and key column alone, and nothing but the key column. Okay, that's BCNF, but let's think about it very well. Order ID, right? Jollof rice, does it depend on the order ID? Item, does item depend on the order ID? Does quantity depend on the order ID? That is it. Order ID here, customer depends on order ID. Restaurant ID, see that we now have a restaurant table, because the restaurant ID is what we need here. Which restaurant is this order coming from? And then when we have this, we now have the restaurant city and the restaurant name on the restaurant table. So anytime we are referring to that restaurant, we don't need to start all the columns that this field that describes this restaurant. Because of space is why we have just 3 columns. It could be more, right? Restaurant type, maybe it's Chinese. I think we have that on our restaurant table in the this thing. So restaurant type, restaurant what is it called again? Restaurant. You can even have segments. You can have signature dish, specialty, restaurant owner, registration number, and all of that. Now, a table is considered to be in a normal form when it fulfills 3NF. Another thing I did not also say is that when you go through the textbook and you read this 1NF, 2NF, and 3NF, 1NF, for 2NF, you must already first fulfill 1NF. So a table cannot be in 2NF without first fulfilling 1NF. And that is because you cannot here now start having maybe jollof rice and beans. If jollof rice and beans is just one item, it's fine, right? But if there are 2 separate items that the restaurant is counting, you understand? If it's just one plate that is named jollof rice and beans, that's fine. Right? That is the unique name. That's how the restaurant is selling it. But if the restaurant is selling beans separately and they sell jollof rice separately, and you have to buy those ones on this thing, if you are recording it together, there is problem. Or if you are recording jollof rice and the quantity together, that becomes another problem. Now, BCNF is Boyce-Codd normal form. This is a rare. There is always this one is. It's not every issue that you will see it. It's always for this for some special cases. Every BCNF, every determinant is a candidate key, right? 3NF has a rare blind spot when a table has overlapping candidate key. You understand? So when you have a candidate key means a key that you can also use for that can be used as the primary key, or combination of rows that can become the primary key. BCNF is stricter version that closes it. You will meet it rarely in real life, but when you see BCNF, you should recognize it. A rider is assigned to one zone per shift, and one zone has one lead. If zones determine lead, but zone is not the table key, 3NF can still pass why the anomaly hides. You understand? BCNF force zone to be a zone. You now have a zone table. You understand? And it moves that key out. The rule of thumb is that um, um, reach 3NF deliberately, then check. So when you are trying to do normalize your data to put it in a normal form, first thing to do is to try and achieve that you're already in 3NF, third normal form. If you are in third normal form, any other thing after that may be aṣeju, right? Just check if there is something that is secretly depending on another thing that's sneaking. You understand that you have overlapping candidate key, right? Maybe there are some other columns that could be key columns on themselves. So for example, you might need a state ID. You understand? If you are depending on if that is something that your business track people by. You understand? So for example, if it's kind of like I'm trying to look at something where, let's say we are dealing with plate numbers, right? And we need to because there is a zoning regulation that certain vehicles, okay, let's say, let me use permit. You understand? You know all those stuff that local government people give, right? If we are tracking all of this, so you have permit to work in Ajegunle, you don't have permit to work in Ikeja. You have permit to work in Ikeja, you don't have permit to work in Yaba, and all those kind of stuff. Maybe it's a restaurant thing that they can have branches all over. You have to check for BCNF in that case. Or restaurants, we have booker out here, we have booker out there, we have booker out this thing. How do you track it? How do you determine? And we still want to record everything that is booker out on our listing. There are different ways we could do it. Each booker out could be different entity, but then we need a parent this thing to link that this is how much booker out is making from our app every other listing. Those are some areas where BCNF comes in. I rarely touch BCNF because it's one very very hard concept to look into. John, I see your head is crashing you, right? What is this thing? Which part do you not understand? It's actually easy.
Because I think maybe understanding BCNF and maybe for the tester.
Yeah, because it's not something that we is because third normal form does have one flop. You understand? When there is a very when you have candidate keys that are overlapping, right? How do you recognize it and address it so that you can break it further into um, its own table? That's why you can read more about it. Boyce-Codd normal form. It's not, you know that normal forms can get to, there is 4NF, I think 5NF, and so on and so forth, right? But the rule is that when you reach third normal form, you are considered to have, it's more like you have gotten to where you are going. And we can take a look at some of our tables because of the way. Let me bring in this our, if I bring in this, just a minute, bring in this our table. This is our BKF, and when you look at this, our Lagos logistics database, you can see that we have order here, right? And let me even look at sample data. Let's sample the data because we have order and order item. Order item is in third normal form. If not, we will Okay, starting the server. Good. If not, we will just mingle everything together. That is why we have all of these tables following each other. I'm waiting for that table to come up. And if we look at the sample data here, this is restaurants. We have riders, and we have uh, customer. Let's go to sample data others. I thought I was looking at that. Good. Right? We have the order ID, the customer ID, the this thing. And when you look at this on this particular table, you will realize that everything on this table, because this table, is it in the third normal form or not? It is. Every column depends on the order ID. There is no partial or transitive dependency. There is nothing that depends on maybe if we have restaurant name here, right? This particular order is coming from a specific restaurant. So if we have the name of the restaurant, we might be like, this restaurant, it depends on the order ID. That's correct. But restaurant name would also depend on restaurant ID on the same table. That is what we call transitive dependency. So there are two kinds of dependencies that you want to correct for your table to be in proper listing: partial dependency and transitive dependency. Partial dependency means that you don't even depend on the primary key at all. You understand? Anything that does not depend on the primary key, that one should get out first. You understand? So you depend on another thing. That thing now depend on the primary key. Because let's look at this. Maybe I'm trying to look for good examples, right? It depend. That's partial dependence. If it is transitive, you depend on not just the primary key, but you depend on another column. So we can take you out. So if you look at this now, just have it in mind that every of your column must depend on only the primary key, right? Customer ID depends on this. Restaurant ID depends on this. Other starter depends on other ID. The time it was placed and the amount. Now let's look at the other item, because the other item is actually where the menu comes in. So if we take a look at the other item, which is what was actually ordered, you see how quantity, unit price, and subtotal. You see that quantity, unit price here, and subtotal is also something that you can look at here. So if we go back to our orders table, you can see that here we are not even talking about what is it called? We are not talking about the order quantity. That's because the dispatch rider does not care if you order 15 fingers of chicken, 10 this thing, and all he wants to do is, I need to deliver my order. I need to let's look at restaurants, or let's look at deliveries. Yes, deliveries is what concern the rider. Do you get? So if we look at the delivery, you have a order that you are delivering, right? You shouldn't be. You see that order ID depends on delivery, on the delivery table, right? And rider depends on this thing. Now, depending on your business, or maybe the order is very huge. Let's say you are ordering something for a party of 200 people from our restaurant. One dispatch rider cannot carry that one at the same time. Now, this is where data helps operation, right? This data has been modeled for individual ordering food, not offices ordering pizza. If my workplace now were to order pizza for every customer, that pizza will not go on the back of cannot go on the back of one dispatch rider, right? With the motorcycle. Maybe they will need to bring a bus to come and deliver that special order. But you have to think about how these framings does change sometimes, right? Because you might be in a situation where you are now going to advise the business. Instead of saying order to rider should be one to one, or delivery to rider should be one to one, right? We can have a particular delivery having multiple this thing. Now how we are going to design that one is even another issue entirely. It will mean we have to break this we can say delivery batch or something. We have to put some sort of ways to recognize that unique push by a particular customer to go and deliver one particular uh, order. Now let's look at from our signature way of doing things here. Let's see when we say let's go back to slideshow. We are already in third normal form. In fact, we got to BCNF here. And some three things people get wrong. Thinking 1NF, the first normal form means more table. No. What you need, you don't need to start breaking things into table from first normal form, is the atomic values and a clear green. What does one row represent? If one row is not unique on your table, you are not fulfilling first normal form. You are still on a particular table. So a row must be unique. And how do you test uniqueness? Primary key. All right. But primary key doesn't just mean one column. It can be a group of columns together, right? Bringing columns together. Then one NF, you can achieve one NF with one single table. You don't need to break things down into other table. Mistake number 2, if you are normalizing based on what is it called, like what I just said now, on what you see, pick a sample data set. In fact, let me try and explain how analytics work for you. And this is really how data modeling should work in real life. You know, the analytics process starts from, so you have business questions, right? So because when you do analytics is trying to ask business, what do you do? So a lot of times we as and a lot of people that are just learning data analytics and all the rest of them, we maybe you go to cargo, you've gotten the data set. That's how most of us started. That's the way things used to be for us, right? We get the data set, we have a lot of data, and we want to start analyzing. And then because you are still learning, you are still practicing, you are like, I have this data set with maybe 1 million rows. What analytics can I do on it? Then you start analyzing. So maybe you go to open weather data, you got your weather data, and you start analyzing. Or some sort of any data you get from cargo. Maybe it's Iris data set, New York taxi stand, all those popular data sets that you know. Not that they are bad. I mean, they teach you how to build certain skills. But in real life, right, you don't get the data and say, what analysis can I do on it? And I've seen a lot of people make this mistake. You go to business requirement gathering, you just ask them, where are your source systems? They tell you the source systems. And here you go. Start doing your own data profiling, everything. Then you build dashboards and all. And then you come back to the business and you have built analytics that they did not ask for, or they don't even need. So everything, you must start from the business question, right? The first thing is, the first step in every analytics, this thing is business question. So what does the business want to know, right? The business question. We want to know if our riders are efficient. Now, efficiency, we have to define it. Is the business that will say, one rider, one delivery, right? If you model just based on the data that you have, you might make a mistake, right? But when you model according to the business rule, say one restaurant, one menu, that does not make sense. You understand? Then they will tell you one restaurant can have multiple menu. Do you get? Oh, can a customer order from two different this thing? And you might be saying, oh, one order, one delivery. But one delivery can deliver two orders, and that happens to a lot of us. Like maybe you order something from Temu, or you order something from Jumia, multiple things on different days, and you get to this thing and they are delivered at the same time. Why? It's because, this is a case of the man, but you can also have a coincidence that the same dispatch rider that is bringing, but of course the delivery this thing. But then the business room might say no, we don't do that. Every single delivery must be one order. Now a rider can have it in one trip. You understand? Make two deliveries to you in one trip, or in multiple trips. Again, those are things that the business decides. It's not the data that you use to do that. I remember when Uber first started, you can't do relay, right? You can't say you drop someone off here, you can, but now you can add stops, right? And I think Chowdeck has this relay something. I've forgotten, because I don't think I've used it, where you can order from multiple restaurants and only one rider will bring it for you. Because you might prefer the rice of other spot, and the chicken from one other this thing, or the coleslaw or the salad from Olive Garden or Olive Green, right? And you bring everything together and it becomes something. Again, those are not decisions that you make. And the business questions come from your meetings, your requirement gathering, and it's always a problem. And you ask them, what are your KPIs? What is your pain point? What are you trying to do? How can data improve your decision making? Because remember, this analytics is trying to improve operations. Operations needs to make decisions, right? That will further enhance the operation. If those decisions are hard to make, you understand? If you are building analytics for decisions, it is after you do the business question that you now start your exploratory data analysis, data profiling, let me call those data wrangling. You understand? You start preparing the data before you now generate the product. And I use generate product here because generate product, or let's say data product. And these are my words, so they are not textbook words, but you are going to understand it in the sense that it is not always a report that you are doing. The result of your this thing may be an ad hoc dashboard, it might be an API, it might be a machine learning model, it might be an AI solution, it might even be automation, right? That some things will work together. All you are doing is to use the data to serve the business, to answer the business questions, to make sure the business is better served. Case in point, there was a time we were building certain report for one of the major banks, and I've told this story in a lot of other fora, right? This was the first time they were using Power BI, and our principal consultant then wants to impress this bank because it's huge, right? And we started building all kinds of dashboard because give us access to all their data. They didn't even know what they. Then we built several because there were two units that we were going to. We started with retail and e-business division. Then when we got to the e-business, we presented everything. They were wild, right? It's like the first time they are using Power BI in the organization. I mean, there is an org-wide initiative, and they were so happy with all the visualizations and all these things that we've built and we've come up with. I think we built 25 dashboards in that particular listing, and only 5 was relevant to them. Only 5 makes sense. So there are 20 other dashboards that we built that was completely useless. It did not answer any business question. It's just us trying to come up. They will like clinical analytics for this. That was not what the business was asking for. So don't make that same mistake that we made those years back. Always try to align with the business alignment. You understand? Now, um there is always a query pattern too. There's another mistake, treating 3NF as a finish line. It is not always. You understand? Some redundancy and some issues can still come up. It's possible that you need to go a little bit further from 3NF. It's very rare case, but it's not like, oh, you must always stop at 3NF. You can go BCNF. That's Boyce-Codd normal form. So what we've learned today, first NF, atomic value, no repeating group of column. It makes the grain become explicit. What does one row represent on your table? You need to be able to say it. And what one row represents must be unique to one row, not you'll be having duplicate. You understand? No partial dependency, that's 2NF. You must first fulfill 1NF first before you go. So it's building on top of each other like a tree, right? So no partial dependency, non-key fact depends on the whole key. So you cannot depend, and 2NF is really in cases where you have composite key like we had, right? Where you can't depend on one, you depend on other ID but no item. You understand? 3NF, no transitive dependency. You must depend on the key column alone and nothing but the key column. BCNF, every determinant is a candidate key. So it's even very, very strict. So tomorrow we will look at denormalization, which is like the reverse of this. You understand? We remove dependencies today. We remove redundancy. Tomorrow we are bringing that redundancy in on purpose, and we will learn about it. So that is where we now start modeling for analytics. Any questions so far so good? Doing
Yes, good morning.
good morning.
Good morning, everybody. It's been a while. So I want to ask, this normalization, how is it related to the fact and dimension table?
So there is a type of denormalization. So in fact and dimension, you are talking about OLAP, right? And we are going to get to that, right? But that is in another system. In that case, we are denormalizing. But fact and dimension is more about even planning around how to answer the business question. What is the fact? What is the dimension? Dimension explains. It explains category. It explains a fact. A fact is a business transaction that you are trying to, maybe a sum, the amount. That's a fact. You understand? But the color of the food, that's a dimension. Do you get? But we will still get to that place. It's all tying together. This is the first normalization is more about the system that even gather the fact and the dimension. Because when you are gathering the data on operational systems, you don't look at facts and dimension. It's on analytical systems that you look at facts and dimensions.
Okay, thank you.
You're welcome. Any other question? Mafi, can you?
Yes, Mr. Ola, this understanding business alignment now. So if you're not eligible, or I don't know how to say it now, the client is not available to give so much information. Do you have to spend more time trying to understand the data in terms of the grain level, what the business wants to achieve? Or I don't know how to go about that.
So
it looks like
even doing business alignment doesn't mean you won't do your own research around the data, because sometimes the business doesn't even know how the data is structured. That's a different exercise, you understand? But there are certain rules that should come from the business. In fact, we are not even talking data quality here now, because what is an active customer? Because the business may say, oh, we need to be seeing active customers. What's an active customer? Is it where the customer status is equal to active, or a customer that placed order in the last 30 days? Do you get? Those are the kind of things that come from the business. And yes, in some cases, you might have a non-cooperating this thing. This is where those soft skills that you wrote on your CV that you have, that is where it comes in. Number one, you have to be patient, because at the end of the day, customer is the king. Your client is the king, and they may be in the same distance. So you have to try every means to reach them. Now, when that does not work, you can assume. Now, what I've seen that happen, and this is like a agbaak, is that sometimes you will design something and say, let them validate. Because when you send them something, they will say, no, you've not considered. Now they will start talking. Do you get? And sometimes you have to show value first. You have to build some sort of a dashboard, show them, does this help you? Ask for feedback. That's when they will now say, oh, there is this other dashboard that would have needed. There's this other one, there's this other one, there's this other one. So a lot of times, yes, you will face, because real life is not that straightforward. You will have sometimes that customers will just not cooperate.
Thank you, sir. Thank you.
All right. Thank you everybody for your time today. It's been Breakfast with Data. See you tomorrow when we look at denormalization.